Imagine stepping onto a world bathed in perpetual twilight, where the sun never rises high in the sky. This is the moon's south pole, a frozen alien landscape where towering peaks cast eternal shadows and temperatures swing from 130 degrees Fahrenheit under sunlight to a bone-chilling -203 degrees Fahrenheit in darkness. Who would dare send astronauts here? Yet NASA's Artemis program is headed straight into this darkness, betting that this dangerous frontier holds cosmic treasure. NASA admits it's a massive challenge, but believes the payoff could include some of the greatest discoveries of the 21st century. The lunar South Pole is extreme in every way. In sunlit spots, it can scorch you, but step into a crater and it's eternal night. Some craters haven't seen daylight in billions of years. These permanently shadowed pits trap any frost or gas that drifts in, making them natural time capsules. Ice and other frozen chemicals may have been locked away there since the moon's birth. For example, the Malapert Massif, a tall peak near the pole, has been chosen as a landing site precisely because it enjoys nearly constant sunlight, while nearby craters lie frozen dark. Still, this frigid hell might be a goldmine. Decades of orbiters and impact probes have overturned the idea of a bone-dry moon. In 2009, NASA's L-Cross probe crashed into a South Pole crater and saw water ice spray out from the impact plume. Today, we know there's significant ice in the polar soil. And that ice is worth its weight in gold in space. Split H2O, and you get oxygen for breathing and hydrogen for rocket fuel. NASA's rovers are being built to sniff out this ice and other frozen resources in the soil. Humans will want to drill and sample that ice too. NASA scientists literally call the polar regolith a 4.5 billion-year-old time capsule. By taking deep core samples from those dark craters, astronauts could read the moon's origin story. Did a Mars-sized collision birth our moon? The answer might be preserved in those icy layers. If this gamble pays off, those samples could rewrite our understanding of Earth and the entire solar system. In fact, NASA notes that using lunar ice could drastically cut what we'd have to haul from Earth, meaning fewer supply rockets full of oxygen and hydrogen. But how do you mine ice you can't see? It requires extreme technology and extreme caution. Satellites like the Lunar Reconnaissance Orbiter have already mapped the terrain and lighting, giving planners safe landing zones. Still, even with maps, one wrong move and a lander could tumble into the abyss. That's why engineers are building rugged robots. NASA's Viper rover, for example, will drive into pitch-black craters with its own headlights and a meter-long drill. Artemis 1, an uncrewed test flight, even carried CubeSats to hunt for lunar ice, and will soon deploy Viper to create the moon's first resource map. Robotic pioneers have already tested these ideas. In March 2025, a private Nova C lander carried NASA's first ice drilling experiment, Prime 1, to the South Pole. It successfully dug into the frozen ground and detected trace water and carbon compounds, proving that the hardware can survive in that polar vacuum, even though the lander itself ended up on its side after only 10 hours. NASA hailed those 10 hours of data as a major victory, because every scrap of information from this harsh environment is invaluable. What if the ground itself turns against the explorers? Studies warn the moon is still cooling and cracking, even at the poles. One analysis found the strongest shallow moonquake on record probably started under the South Pole. That means a sudden jolt could strike any crater without warning. If the ground shifts, icy soil might start to slide. Models show even a light lunar tremor could trigger an icy landslide in those shadowed pits. Engineers are even drafting lunar building codes to brace habitats for these possible shakes. And the perils don't stop there. With no atmosphere or magnetic shield, the poles are bathed in cosmic rays and brutal solar flares. Astronauts will need bunker-like shelters and heavy shielding to survive a major flare. It's not for the faint of heart, yet space agencies press on. The potential payoff is too great. As one NASA leader put it, exploring this extreme polar environment will help inform future landing sites and better understand the Moon's environment, knowledge essential for sustaining humans off Earth. This high-stakes mission has become a global race. NASA plans to land Artemis 3 astronauts at the South Pole by the late 2020s. The first human return to the Moon in over 50 years. China's Chang'e 7 and 8 around 2026, 2029 will probe the same icy highlands and even test 3D printing lunar habitats from soil. India's Chandrayaan missions also target polar ice. Even private companies like SpaceX and Blue Origin are in on the act. Put simply, it's a 21st century gold rush. Whoever controls the South Pole's resources could dominate the next era of space exploration. We really are venturing into the unknown. Imagine future astronauts standing at a crater's rim with Earth rising overhead, scooping ice no human has ever touched. Every gram they collect will be like unlocking a treasure chest of knowledge. This gamble may sound crazy, but it's driven by human curiosity and necessity. If the Moon's ice is truly there and usable, it could fuel missions to Mars and beyond, a payoff worth the risk. If you're hooked by lunar mysteries, hit like and subscribe for more space adventures. What do you think? Is the South Pole worth the risk? Leave a comment with your thoughts and theories. I read every comment and will reply to each. Thanks for watching, and good luck out there on the Moon.